Hey, if you're just joining us, we're going to get started pretty soon. Introduce yourself in the chat, start thinking of questions, and we'll be getting going in just about another minute. And just a reminder, please complete the survey at the end of the workshop. Okay, let's get going. It is time. So welcome everybody. Today we're going to be learning how not to let flaky tests disrupt continuous integration. And Rohan and I are your speakers. Rohan is a senior product manager based in Toronto for CodeCov at Sentry, and I handle product marketing here in San Francisco. So here's a quick agenda. We'll start with a little background on failed and flaky tests and how they can make developer life hard. And then we're going to talk about how to handle them. And then Rohan will hit you with a demo. And then we'll wrap it up with some Q&A. So, please ask any questions as you think of them in the Zoom Q&A, or if you're watching on YouTube Live in the chat. Okay, so let's get started with a quick gut check on failed and flaky tests. This is probably obvious to most of our audience, but I do want to set the stage in terms of what different things mean and what actions they mean you should take. So a failed test means that a test was written for a given chunk of code, and when it was run, it didn't return the expected result. This would be your indicator that since the code failed the test, you need to then fix the code. Then a flaky test is a test that sometimes fails and sometimes passes without the code in question having changed. So that can be a problem because if you see a failure that you didn't realize was actually flaky, you might either change code that was actually fine, or at least you're going to waste time trying to figure out why your code failed when, again, actually it's perfectly fine. So why and how do tests become flaky? There's a lot of possible culprits like reliance on external services, like an external service that would experience an outage, or race conditions, or maybe a dependency on shared resources, or timing dependencies, test order dependencies, infrastructure problems, all kinds of possibilities. Or it could just be a poorly written test. And then maybe more importantly, how do you know a test is flaky? So traditionally, this would knowing this for sure would mean that you're going to be doing manual work, like either analyzing test logs or rerunning a test repeatedly to see what happens. But honestly, a lot of times developers are going to just have a hunch that a test is flaky and treat it like it's flaky without knowing for sure. So how do all these problems impact developers? One flaky test here or there, might not be a big deal, but over time they can build up, and you have a test suite that's going to be full of unreliable tests. And if you can't trust your tests, then they're essentially useless. So that problem can spiral into a situation where you actually just don't trust your test suite and you're running your tests just to check a box, and then your code quality suffers and you're dealing with more bugs. It's kind of a negative kind of spiral, downward spiral, if you will. And flaky tests also are going to mean that you're going to be spending time running and rerunning your tests or your CI. And if things get even like worse, then for instance, like a lot of those tests, if they are taking a long time to run, it might even impact your CI's performance. So that's enough time with me kind of frothing up all the bad feels. Let's talk about what the solution is going to be. So the good news is that it's actually pretty simple to break it down into 3 steps: detect, act, and improve. So your first step is detect. And that's what happens when you enter a commit. Using CodeCov, you're going to see test information right in the PR comment with failed and flaky test alerts and stack traces. Then you're going to act. Act is what you do with that information right after you see it. You'll use it to fix your code and deal with any flakes. And then finally, we have improve. So improve is your longer term plan to reduce flakes and make your test suite run better. So that's kind of the basic description. Rohan's going to take it from here and show you exactly how this all works with a demo. Rohan, take it away.
Thanks, Lindsay. Hey, everybody. I'm Rohan, a senior PM on CodeCov. And I really like the way Lindsay talked about, managing flaky tests and problematic tests within the framework of detect, act, and improve. And in this demo, I'm going to show you each and every one of those stages. But before we do that, I just want to quickly touch on how you would even get set up with test analytics from CodeCov. So if you're already a CodeCov user today, all you really need to be doing is just log into the CodeCov app, assuming y'all can see my screen. But all you have to do is just go into the CodeCov app. You'll find a new tab called tests here. And once you click on it, you'll find setup instructions on how to integrate test analytics with your repo. Now, if you're already using CodeCov, you'll realize that integrating with test analytics is like very similar. It should feel very similar to you. You're essentially instructing your test runner to output a test result file and instructing the CLI to upload that into CodeCov. That's very similar to how we integrate with coverage today. So in the instructions here, you can find, so we have dedicated instructions on if you're using GitHub Actions as your CI or if you're using any other CI. So the first step is going to be to output a test results file in the JUnit XML format. So JUnit XML is a format that is pretty much an industry standard. So if you're already using a test runner like PyTest, Vitest, Jest, or PHP unit, you should have that. You should have the ability to output that out of the box. Most test runners that fall outside of these also do support JUnit XML. And we have more detailed instructions for some of the less popular test runners in our documentation as well. So once you instruct your test runner to output the test results file in a JUnit XML, if you're using GitHub Actions as our CI, you can use our test result action that we have built. You can integrate, you can add this code snippet to the end of your test run. And all this is basically doing is finding this file and essentially uploading that into CodeCov on every commit. If you're not using CodeCov already, I highly recommend that you start doing so. And you can just log in, you can just visit our website, codecov.io, and try CodeCov for free. So with that, I want to now dive in to like the meat and potatoes of this demo. So in preparation for this demo, I threw up like a pretty basic Python application, which is basically like a calculator. So all it does is like take two variables and runs a bunch of operations. I also have tests for them. And like I put myself in the mindset of like a developer. Like let's assume that I'm adding like some more functionality. So I made some changes to the code and to the tests, and I pushed up a pull request. And now we're going to see what happens as CI kicks in. So like in my pull request, I noticed that my CI has run. So behind the scenes, what's happening is like once CI is running, if you have CodeCov set up correctly, CodeCov will receive a coverage file and a test results file. But I've noticed that my tests have failed. So already you can see that we have one pretty nifty improvement from the regular developer experience in that we are outputting the failure and the stack trace as a comment in the pull request. Without this, as most of your developers, you would probably know what the process was to diagnose a failure if you didn't have this. You can imagine that you would probably have to find the run yourself, like into details, uh, and then navigate to the failure. Now, obviously, this is like a very simple case, so like it's pretty easy to find the failure, but you can imagine scrolling through lines and lines of stack traces trying to find the failure. So having the failure front and center out here is really helpful. And I also noticed that it's a flaky test here. So what that means is that we have received test results for this test over a period of time. And we have noticed that on a PR, which is different from this, that this test has gone from pass to fail on multiple commits and has been checked in with a failure. This is a key sign that this test has an indication of past flaky behavior. And because I am now encountering a failure on this test, it's a signal to me that it's possible that this is no longer that this failure isn't necessarily related to the change that I'm making. So what I can do at this point is like look through this stack trace or specifically the error message and try to figure out if the way that this test is failing is indeed related to my code. I can also copy the fully qualified name of the test. This is really useful because then I can copy and paste it into my terminal and run it and see if it runs fine locally. And once I determine that if this is really a flake, at this point, I have a couple of options. If I have written the test or I'm familiar with the test, then I could go ahead and change it so that it no longer flakes. Or I can raise it to some members of my team, ask for help. I could rerun it until it eventually passes. Or I can take it out of circulation. So this is very useful to me as a developer, because if I didn't have something like this and I saw a test failure, I'd have to spend cycles determining whether or not this was a failure that was as a result of my change. And you can imagine how that could be frustrating if at the end of the day you realize that this was like. But most of the times, like if you encounter a flake, or if you encounter, or if you're dealing with a test that can be a flake, things might be fine, like it might pass, and you may be none the wiser. But the test still, but the flake still exists in your test suite. So what do you do? Especially if you're a leader or a manager, the cost of these flakes and these retries actually manifest as longer CI runtimes or more times spent running CI, which leads to cost increases. That's why we build the test analytics dashboard. So if you navigate to the test tab after you have integrated, you'll find a list of analytics that that encapsulate like key metrics for your overall test suite. You can think of the metrics in like two broad categories. Like the first category that I can think that we have here is around reliability, which talks about flake rates, number of flakes, number of failures. And the second aspect is runtime. We also have a list of tests here across all of, along with the metrics against those dimensions. So this is really useful because it allows me as a lead or a manager to plan improvements for my test suite. Even within CodeCurve, we've realized that some of our tests take much longer than they should. So for example, this test takes like about 9 seconds. This takes about 4 seconds. And like we know intuitively that it shouldn't take that long. So you can use this as a way to kind of figure out which tests take really long or which tests tend to flake a lot and figure out whether you need to optimize them or you can take them out of circulation. You're also able to slice these metrics by different time dimensions by using the historical trend dropdown here. You can also sort by test suites. And lastly, if you're running tests on multiple environments, uh, all you need to do is tag the test uploads using what we call flags. And say, for example, you're running your test suites on, you have test suites for Mozilla, Firefox, or Chrome, Internet Explorer, if you're still testing on that. Um, those would you can set up code curves so that you're sending them as sending those reports as flags, and you would be able to sort through that as well and get like metrics that tie with those environments. You can also switch branch context. So if I'm working on a feature branch, I can look at the individual, I can look at the test runtimes and failure rates against my branch. And that is really useful if I'm trying to plan improvements to test runtimes before merging them into main. Or let's say that I have added more tests. I, I can then see how the runtime for that test increases and then compare that to runtimes in main and then see if that makes sense or not. So overall, like if you think about the three principles Lindsay talked about, which is detect, act, and improve, you like hopefully you got a glimpse of how the pull request experience and the UI analytics dashboard uh, together help you uh, detect, act, and improve your overall test suite health. That's it for the demo here. At this point, I'd like to flip it back over to Lindsay for the rest of the webinar. Thanks.
Awesome. Yeah, thank you, Rohan. Let me share my screen one more time. Okay, so demo time is over. And now we've got some time for Q&A. So we got some questions in the chat. Thank you for those. We also got some questions ahead of time. So we'll tackle those. But again, if anyone has any questions that come up, go ahead and submit them in Q&A. Okay, so first question. Can you add some more detail on what causes tests to be flaky? Rohan, I'm going to ask you to answer this one. You are on mute.
Indeed, I am. Okay, thank you. Yeah, so I think Lindsay, you covered like the basics at a higher level a little earlier. I can talk about some of the common instances that we have seen in CodeCup and at Sentry, and really like we have seen like three different types of flakiness that we have run into. So I'll describe them here. So the first category is like when tests unfortunately aren't just that thorough. So a good test needs to be as deterministic as possible, right? So that when it fails, it is like a true failure. So within a test, you're asserting or testing a lot of assumptions. So you have to try to make sure that you're testing as many of those assumptions as possible. And in some cases, you're either like missing an assumption, or like for some reasons, like not all of them can be checked or enforced at any given point of time. And if that happens, then like during like when your code runs or when your test is being run on a given change, you might find inconsistent pass or fails, which can lead to flakiness or behavior that feels like this test is a flake. So that's like the first one. The second one is for async waits. So this is like pretty common, at least in my experience. I've seen a lot of, I've seen this pretty common in like if you're writing JavaScript code. Effectively, what that is that sometimes you need to give a test time to complete the request. And like I've seen instances where you would try to do this by like you could do this by writing a sleep statement, and like you could say, yeah, I'm going to like pause this for 30 seconds until the application finishes what it needs to do. Sometimes things might take longer than that, which could cause tests to fail. The third category that we have seen is that I could have a test that is depending on a third-party API or infrastructure that needs to be spun up, and maybe the API is down, or maybe the infrastructure that I'm waiting to spin up just failed, ran out of memory, which then caused the test to fail. So all of these failures have nothing specifically to do with like your incoming change. Um, and so like if you retry it, sometimes it may just go from fail to pass again. So that smells like a flake. I saw also someone talk about time dependent tests. Yes, that would also be an example of that.
Awesome, thank you. All right, next question. Okay, so, and we had a similar one to this in the chat too. So, but basically like how accurate is your flaky test analysis? Can I trust it? How do we know? How do we know it's flaky? How does CodeCov know it's flaky?
Yeah, so I mean, so when we launched this, we made like a conscious decision to be like conservative in our flake detection in order to minimize false positives on the PR comment. Like nothing is worse than like a developer seeing on a PR comment that a test is flaky where in fact it's not. That leads to erosion of trust. So like we were like pretty mindful of that. So currently we focus our flake detection on tests that display fail, pass, fail, pass, fail, pass, fail, whatever, as long as many comments you have on a PR. And if it was checked in as a failure. So what we found is that this does a reasonably good job of catching flakes that exist in your system after we've built up like a history of failures on it. And we found that when we tested this with like our beta customers of at least 50 or more, I can't recall at this time, that this tended to be pretty accurate, but also um, like because we were being conservative, when we did say that this was a flaky test, like it was something that um, like was backed up by the failure history that you would see if you manually went in and inspected like the stack trace and like other instances of it running. So yeah, like I think like to answer your question, can we trust it? Yes. Like I think we've tried to make sure that we're conservative and accurate while reducing false positives.
Awesome. And it sounds like you've heard from beta customers like that they're confirming that, yeah, it's correct.
Yeah.
Yeah, awesome. Okay. One last pre-submitted question before I get into some more questions. And I can take this one. The question is, does this feature cost extra? And the answer, of course, is it depends. So CodeCov has 4 different possible plans: developer, team, pro, and enterprise. And then you also have whether you would have either a private repo or a public repo. So the first thing is that, we always want to support open source. And so for open source repos, public repos, everything is always free, right? Like you're not going to pay for it. And this would be available for your, public open source repos. On private repos, however, the test failure information is available with your plan, whether it's the free developer plan all the way up through for with no additional cost for all of the plans. But the flaky tests are available for private repos on pro and enterprise plans. So if you are on an individual developer plan or a team plan for a private repo, you would not get the flaky test element of the plan. Okay, I think I did that correctly. So now we've got some more audience questions. So, okay, we've got let's see, we've got one from Brunings, and hopefully I'm pronouncing your name correctly. Apologies if I didn't. Do you have some management features, like for instance, assigning tests to somebody on the team to fix?
So I can take that really quickly. The short answer is not at this time. The longer answer is some of the features that are in our roadmap that probably align with this to some extent is like we want to be able to pull the git blame of the test. That makes it easier for you to see the who the person is who created this test. Some of the other ideas that we have seen come in is being able to create an issue. So like if like on the screen you would see like a test that is flaky, you would click that, you would automatically create like a GitHub issue that could then be assigned. So this is feedback that we have gotten. It's on our roadmap.
Okay, great. All right, another one from Brunings. And I think this is going to follow along the same lines as the first one in terms of what your answer is going to be, but do you have any clustering based on the exception or failure across tests?
I am not sure what is meant by clustering necessarily. Is it possible for you?
I think this
Go ahead.
person might be saying, and Brunings, let us know if we get it right or not. But what they might be saying is, are we able to, like, depending on the type of failure or type of exception, are we able to group the tests by type of basically failure?
I see. Okay. So the answer is not currently. We have in our roadmap the ability to match according to error messages and present that in the UI. I think we have a little bit of more work after that to kind of like create patterns around those type of failures based on analyzing the error messages. So that specific piece isn't necessarily on our roadmap just yet. I expect that to be a little further out, but like I'll be sure to add this for consideration.
Cool. Thanks. And yes, Brunings did confirm that yes, that was the question. So thank you so much.
Awesome.
Okay, we have one more. I think this one you might not know. I don't know. I don't know. But we're gonna find out. Michael's wondering if we implemented the flakiness detection algorithm that was described in the 2020 Apple paper.
I am not sure.
Okay.
I would like to get back on that if possible.
Perfect. Mitchell, we will get back to you. I also have no idea whether that was the particular algorithm. Okay. If there are no other last minute questions, that's all the questions, and we can kind of keep going. So we've got some resources for everybody. These are going to be added to the webinar chat as well, but we've got a few things. We've got some great like blogs, for example. We've got a blog about catching flaky tests before it's too late. We've got effective strategies for handling flaky tests, and of course, just straight up the docs for test analytics. And also, if you want to connect with Rohan or I on LinkedIn, here's our LinkedIn information. Let's see. I think we're also when we email you all after the event, you're going to be receiving all of these links as well in email. We did, if I can circle back, Rohan, I do have one more question. And is this only available for GitHub or do you have GitLab support?
They should work for GitLab as well.
GitLab as well. Yeah. Sweet. Okay. Sorry to kind of veer a little bit there.
Yeah.
So let's see. That's where you learn more. A couple more resources for everybody. This is where you can start a 14-day free trial. Here's a link to our Discord. There's a tab called resources, and you can grab that in the links. And as our workshop manager mentioned, we will email them to you shortly. So all this stuff is coming to you. And with that, we're going to say thank you. And that's it. Thanks everybody for coming. Thanks, Rohan.